participants can post there. Okay. We are gonna start at 6:40. So grab some tea, grab some coffee, grab things you need to stay awake. We're gonna have a bit of a lecture and then break you off to do some interactive labs as usual. So feel free to chill for a little bit. I'll see y'all in 9 minutes. Going to get my tea in the kitchen. Recording. Okay, great. If anyone else comes in late, please TAs just feel free to add them in.
Yeah, we'll
But
do.
let's get started out here. Okay. Um, so I'm gonna start our lesson with a quick little kind of chat about um R&D, research and development, cool things about that. And basically, this is just a long-winded way of saying there are not many companies you'd be able to kind of do R&D on. So what's cool about I think a couple of y'all will be going to the Air Force. What's cool about that is this whole aspect of research and development you'll more than likely be able to do. Research and development that's kind of based off of um like like basically something that low key doesn't necessarily need to be profitable, but needs to have this discovery aspect there. So, has anyone heard of the research lab called Bell Labs before? I probably mentioned it on Saturday, but y'all were out here being like, "What is that, Grandpa? Like, go home, you're senile." All right, the TAs don't count. All right. So basically, um, the company y'all now know as Verizon, used to, be Bell, like they were called Bell, and they used to basically, well, I guess they still do research and they're not doing it the way they used to, but there used to be this really cool innovation lab for mathematicians, scientists, all that stuff to kind of like bring the best, brightest minds together to basically like do research and development to advance it was humankind, but really it's for like like for the Americas. And one of the cool things that like this little phone company that now nickels and dimes you for everything you now do, they actually created the first point contact transistor. um you know I'm gonna be a nerd here and ask, does anyone know what a transistor is? Yeah. Hey, Kiki, you don't count. You do software out here. Okay, so you know, to save a little bit of time, I'm gonna click on our trusted Wikipedia out here. But basically, transistor is the semiconductor device that amplifies or switches electrical signals and powers. Basically the building block of computers as we know it now. If you hear semiconductor, you probably are thinking of things like the companies like NVIDIA, all the way to, like Taiwanese Semiconductor. I think that's a company, TSMC or something like that. And they are now the $1 trillion companies that are basically the arms dealers of AI. But the craziest thing is this kind of started as this little R&D project from Bell Labs, as you can see from a bunch of these old bush folk out here. So this is kind of like a really cool little innovation that happened, and they had no idea that this was going to change the world. But this was just kind of like a little cool research and development, little innovation that they found from a company, from like basically doing research. Also, there was another kind of innovation lab called Xerox PARC, and they actually came up with the first uh, GUI. And do you guys know what a GUI is? Okay, so that's the graphical user interface. And basically, what that means, it is the visual representation of our computer. My computer is a mess because my life is a mess, but basically, back in the day, we traverse computers through the terminal, very similar to what we do for just for Git. Picture a world where you actually had to do that, um, like just to live your life on the computer. It's terrible. It was very um tech heavy, not user friendly, and kind of did not spark joy for people who wanted to use computers. So um basically Xerox PARC, they kind of created the first graphical user interface. If you kind of see this image here, there it is. So very, very rudimentary out here, but as you can see, it's starting to look kind of like folders that we are used to. Um, if we and funny story, if y'all know the whole history of like Steve Jobs and the first Macintosh, like Steve Jobs was able, and Steve Jobs and team, so it wasn't just him, but basically they were able to kind of go to Xerox PARC and they were like, oh my God, this is amazing. Uh, and here's the interesting thing: Xerox PARC didn't necessarily knew what they had on their hands. So Apple out here was like, "Yo, this is amazing. Let's actually use this for our latest computer." I think it was also the Lisa too as well, but the Macintosh. Okay, spell. Um, and basically, the funny story is they kind of ripped these guys off and was like, "Yo, y'all are sitting on a gold mine and you're not doing anything with it." So they kind of took that same idea and built out the graphical user interface that we kind of know now as our Mac GUI or graphical user interface that we kind of see on our Mac. If you look here, you got the little Apple logo that you're used to. We still have it here to this day. And a bunch of the other kind of elements we'd have when we're navigating through files, Finder, clipboard, all of these things that we now take for advantage. We take advantage of now at this point. A little trash can as well. I think it's called a recycling bin now. Oh no, it's still trash. Recycling is Windows, I think. But um, this again was a really cool innovation that kind of came from a lab. There's not many companies and organizations you're really going to be able to like do R&D for and like make something and not get yelled at for being like, yo, what are you doing, bro? Like you're supposed to be making us another million. So um, I won't lie, outside of the whole aspect that the department is now called the Department of War now, it's which, is wild. But, the thing is like organizations like that, you don't really get a chance to kind of do research and development unless you're kind of you're doing research and development yourself and building stuff yourself. So uh cool opportunity. Actually, one of my first my first jobs outside of my coding boot camp experience was doing tech for good, civic tech at Microsoft. And it was kind of like that because of the fact that it was Microsoft back in the 2015s, where basically it was just like they had all the money in the world to waste on anything they wanted to. This is back when I think research and development was actually still tax credited for companies. So like, yeah, they could just kind of throw money at it, whatever. And, like it was a really beautiful opportunity to actually make something that actually was help people over push the needle of the company's economics. So It's cool, and I think there's a lot of cool aspect there. There are benefits, costs, of course, to picture you build something like infinite scroll and destroy society. But no, but like basically the idea is like you have the ability to kind of do research and development, and that's really cool. Um, cool opportunity. Not really selling all on it, like, but the idea is like research labs and stuff like that are too far and few in between. And as Dr. Kruger mentioned, that's probably the reason why China's going to eat our lunch in the next 10 years. But, like it's cool to kind of work at a place that you would be able to, like do R&D at. So, yeah, take advantage of it. I'm over here making forms to make people richer, and it'd be cool to do more R&D stuff. So R&D stuff that like the R&D stuff I do now is just strictly for my studio at Made in Brooklyn Games. So enough of my rant out here. I'm going to start our lecture here. So what we're going to go over is more JS, so like higher order functions, callbacks, array methods, stuff like that. And then we're going to go through as many slides as we can for the document object model slide so we can kind of get a better understanding of traversing the DOM and how we can kind of affect the DOM there. And then we'll do some labs. Let's see how far we can get. And I hope y'all have your nice tea or coffee ready to learn. So let's start. Bam. All right. So let's start with higher order functions. What the heck does that mean? Basically, higher order functions are functions that basically operate on other functions, either by like taking arguments, taking them as arguments, or returning them. So if you remember from one of our earlier labs and a couple of our labs, the way we represent a function is through something like this. If you finished your in between lab out here, you would have actually went through um, a function that is declared as a variable. And what's interesting about once something is declared as a variable, it's set in a chunk of memory on your computer, so it can kind of behave in ways that kind of feel that are like variables that you like that are variables, long story short. So the idea behind this, you can pass and call these variables. And if a function's a variable, you can pass a function through things like another function and kind of call it between in between functions, which goes into this concept of callbacks. So basically, if we have this function saved as a variable, we can kind of have it behave like a variable throughout our program. So this kind of gives us the ability to treat like our functions as like first class functions, meaning they can be assigned as variables and passed in as arguments to other functions. So here's an example of one. Basically, if we take a look at this example here, we have a function called outerfunc, and it takes in an argument called CB. This is short for like callback. This CB is actually a function. So what we can actually do in this function is call the return output of that function. So if you think of it in the world of Inception or something like that, we're in one function, we go into another layer, and we've passed in basically basically something from the outer function into the inner function to call. Basically, this gives us the ability to invoke this callback and basically essentially delegate some of its functionality to callback events. So why do we do this? This is when you think about the world of JavaScript, it kind of feels like this interactive conversation where you do one thing and then the web page responds, and then you say another thing and then the web page responds. But JavaScript's actually single threaded, which basically means like this thing just runs in sequence. So one of the interesting things about that is like, how the heck are we doing this whole aspect of treating our web page like a conversation if we can only go through one line at a time? And what I mean by that is like, picture a world where we have a function and we're basically needed to grab some data from like the web and then call another function on there. Basically, like, if that data is not ready or like ready by the time we call that function, we'll have an issue. So basically, the idea is like, how do we do that? And we do that through like these higher order functions like callbacks. A lot of we will go, and it's not like you will, but you will actually go through some functions where you're actually playing around with data that's grabbed from the web. And the idea is like, yo, how do you call that function, get that data, but then also know like, yo, I'm gonna be able to uh like like sparse that data, like, kind of break through it and actually populate the elements on the page with that data that I found. It's through things like this. So maybe you'd have like an outer function, and then you have to wait for the data to come, and then you'd basically call your callback based off of that. So this is a higher order function. We're going to go into callback functions a little bit more just to kind of like sink it in a little bit. So again, callback function is a function that's passed in as an argument to another function, and it is invoked or executed inside of that outer function to this, perform a specific routine. I would say like an example of this is, picture a world where you're like working at Amazon or something like that, and then you have a function, you have a shopping cart and you have a function that runs like a discount. Let's say it's the after Thanksgiving sale, Black Friday sale on everything on your shopping cart is 30% off. But also you have a function that calculates something like shipping for all of these items. The idea is like, yo, you can't really necessarily like do you basically would need to have the ability to kind of like discount those functions, those items before you calculate shipping. There's a sequence in there. So go into a little bit from our previous example. Yep. From our previous example here, we have like this parameter of our callback. And the purpose of that is really to just be executed within our function here. There are particular reasons why you would do that on the web. Examples like waiting for like input to be filled into a search field, like on Google, to get data, or the way to basically needing to wait for some certain data to be finished before you can kind of like move to the next line. So these callbacks kind of make the web give you the ability to kind of like give more interactivity to the page. And you'll see that it'll actually be needed for a lot of functions in the future for handling data or handling just events in the world of your apps. So speaking of the world of your apps, let's actually go to array methods. So we all know what an array is, right? Right. But basically, a bracket holding data out here. Let's get a little recap just to make sure y'all remember out here. But our array, if you take a look at this, const r equals 1, 2, 3, this is the structure of an array. What's interesting is we can actually do a lot of interesting things with an array, because this is how we hold data a lot of times in our like applications. It's usually either an object or an array that holds our data, and we have to traverse it or call functions on it. So let's actually go through a couple of functions that will actually be technically callbacks on our array. So here are a couple of array methods. Let's understand this, understanding like the higher order functions and callbacks from this. So like we'll go over 3 of them, but like of course, rest assured there's a bunch more. I would recommend you kind of like looking through them, playing around with them. There will be a couple of labs once I finish them to kind of like play around with this idea of array methods. So first things first, there is the forEach method. So basically what this method does, which is a method on your array, it actually iterates through each element of your array, and it takes a callback function in order to actually execute on each element of the array. So the idea is it loops through your array, and then basically every time it hits one element, it'll actually run some kind of logic on there. And then it'll go to the second element, run some kind of logic on there, some type of, and then goes to the next element, run some type of logic on there, all based off of that callback function that you actually passed in. And important note about this is, remember, the forEach function does not modify the original array, and it does not like return any value. So basically you're just running logic on there. You can actually have console logs, you can pass variables or change variables in different scopes based off of what you find or do in your callback function, or edit your HTML based off of that, but it doesn't modify the actual original array that you're looping through. So let me show you a little example of how this kind of plays out. We're going to go to our JS fiddle here. All right, I can't see y'all, but please yell if you can, if you can't see the JS fiddle here. But basically what I'm going to do is like write a little bit of HTML here so y'all can kind of see some stuff. Y'all can see this okay, right?
Yes.
Maybe so. All right, beautiful. All right, I have some little bit of JavaScript here, a little example here. Let's just pass that in. Let's actually run it and make sure we have some. There we go. So we have our JavaScript array. We're actually going to have a little example for our forEach method here. And we have this div of the ID of demo here. So basically what I want to do is actually show you how we can use our little our forEach here. So I'm going to kind of quickly create a variable here. I'm going to call it text be like equal to this empty string here. Bam. And can I make that bigger? All right, make it a little bigger for y'all so you can see that. All right, so also I want to kind of create an array because of course we'll never really change our array. I'm going to have it created as a const. We'll call it food because I did not eat dinner yet. All right, so first element, feel free to yell out some of your favorite meals. I'm gonna say curry chicken. Anyone else have any recommendations here? Or I just start putting spinach in there? How do you spell spinach? That's probably not. Again, I am a programmer, not a speller. There it is. That's not how you spell spinach. Don't mind me. This is why I never got through a spelling bee. Does anyone else have another food recommendation?
Pizza.
Pizza. I like it. All right. So, because y'all didn't chime in, one of y'all has to eat spinach. But we got curry chicken, spinach, and pizza. So what I actually want to do is show you us actually like making this little forEach here, like an actual example forEach. So I'm gonna I'm gonna call food. We actually go here. I'll show you how this looks. Do I have an example of that? Nope. All right, nope. So great. So we get to just like build this from scratch. So basically, what we do is normally like very much like a method. We're going to call for each on this thing here. So we're actually going to run for each, bam. And as you can see, what's kind of cool about text completion here, you could actually see if you kind of look at the function here, you'll actually see what it takes in, and it actually takes in a callback function here. So we're call it just my func. Give us the func. All right, so it's going to be called my func. And what I want to do is in this function here, my func, what this is going to do is actually it's going to take in two values, which I'm going to actually share. Like what's cool if we actually take a look at the array here, we can iterate over each array, but it also passes in an index argument along with the actual element, so we can actually utilize that in our callback function. So I'm actually going to like take these two items and put them in as variables. So we're going to have our item and our index here. Bam. So what do I want to do here? We have this little text here. I will actually want to, every time we loop through an element, I actually want to add that to our text and call it a day. So basically, let's actually do it this way. So I'm actually going to hit um, a little thing called plus equal. So basically what this means is it's basically the equivalent of saying this, like text equals text plus something else, like what I want to actually add in there. But let me actually show you how this goes first, and then we'll actually, like show you that. So index, well, let's actually not do index right now. Bam. So that's going to equal to text equals plus index plus one there. I actually want this in quotes because it's actually going to be a little string there. Give it some space. Bam. Plus and plus item here. So basically, also what I want to do is give us a little line break so we can actually see it on our page without it basically being clumped up. So if you remember in our HTML lab and lesson, we actually have this concept of a break tag. And that break tag basically means like, yo, put everything else on a new line. So what I'm actually doing here is saying like, yo, every time we loop through this, we're actually going to add to text and add our index where we are in the array, and then basically a little colon there, and then our food item there. And then, yeah, that's basically it. Semicolon there, call it a day. So, yeah, what I'll do next is we'll actually go into this for our DOM model, but basically, I want to show y'all something else kind of cool. Notice that I'm actually putting this function down here. Remember hoisting? I want to show you that that actually works, and I'm not just tripping out here. But we'll kind of go through this, but like in our DOM, we can actually reference the whole window of our DOM with document. So we can call document dot get element by ID. You can see we have an ID of demo here. And basically what I'm going to do is like say, yo, I want you to grab demo here. And I want you to call something on it. What is that? The inner HTML. So actually inside of this little p tag here, I want to grab the inner HTML and edit it. Basically put our little make it equal to our text here. So what are we doing here? We're calling a for each on our food array, and we're passing in a function here. that function is actually going to basically change it's actually going to append text to our little text here, which is nothing right now. And then basically from that, we'll actually append that on our inner HTML with based off of grabbing the document by the ID of demo there. So let's run this. Let's make sure it works. And bam, we got we got ourselves some curry chicken. We got ourselves some spinach. We got ourselves some pizza. This is a good time. So this is an example of how we can actually use a callback function and use it in something that is a method on a array. This array can now be traversed over that way. As you can see at the bottom here, what's kind of cool is we're actually calling my function on line 4, but we're declaring it on line 8. So if you remember from our JavaScript lab, there are different ways we can kind of declare functions. And this way of actually calling function, my func, all of the, like, and then kind of appending the stuff there, this basically hoists our function to the top. So basically, this is already that we already know what my func is, even though it's at the bottom because it's hoisted up. Think of hoisting like a flag. Before we continue, do we have any questions on putting a callback into a forEach, which is traversing through an array in JavaScript? I know I'm not that good of a teacher, but we'll continue. All right, so I have a question now. I don't like how we are starting at 0 because of the fact that, with arrays, we actually start from 0. How could I actually have this element start at B1, this element B2, and this element B3 based off of our our logic here in my func? Anybody, guys? Is anyone awake? Is there anyone out
You can
there?
add like something empty on 0
Oh, so what'd you say?
into the array. You can put the first one as like foods or something.
Oh, so you basically you want to put the first, like, you want to replace index with foods?
Oh no, like see where constants equals foods. Like replace
Mm-hmm.
the first value with just foods and you just never use it.
Oh, wait. Put it as foods and never use it?
No, like in the first value in the actual array.
I like that. That's a see, this is why we program. This is a cool way of kind of doing that. All right, so foods here. And let's actually run this and see. So foods, curry chicken, spinach, pizza. I like that idea. Um, but what I want to actually ask you to do is actually how could we increase the index of this within our function? So we basically start at 1, then our next element's 2, our next element's 3, so on and so forth.
Instead of printing out the index, you could print out index plus one.
All right, I like that. So what I'm actually gonna do, I actually always like kind of handling it this way. So I'm gonna put a parenthesis in between that. So our code logic is a lot of times like math. So basically, I kind of like using parentheses for stuff like that. So let's add 1 to this. And basically our index should start at 1 now. So as you can see, bam, I like that. So foods is 1, curry chicken's 2, spinach is 3, pizza's 4. Um, so what's funny is I was thinking about like how can I show an example, and I didn't even think of like, all right, yeah, actually screw that whole logic, put like foods there first, and then it's a list of foods right afterwards. At that point, you could just like put an underline there, foods, and then scroll down. So I love that. That's a that's how you find a workaround in your programming there. So I like that. too. But yeah, this is like kind of a way we can kind of handle for each here. So any questions on for each before we move on? Okay, so we loop through our array. We have a callback function. That callback function is called in there. That's the vibe. Okay. So next is a array.map function. So what's generally different about this compared to for each is when you really think about it, again, map doesn't modify our array, but what it will do is actually generate a whole new array for us. So basically what we'll do is have like something like new array equals like current array dot map, so on and so forth. So let's actually let me think of, yeah, so basically another example of that can be something like this where, yeah, so basically yeah, that'll work. All right, so let's go back to our JS fiddle and we're gonna nuke it. So what I want to do is let's actually nuke this and make a new array here. Bam. We're still going to use text so we can actually have it put into our like paste on there, but I guess we'll do numbers now because this would be a good idea. Numbers, and I have a little bracket there. I have like basically like 1, 4, 8. Someone else give me a number that's higher than 8.
12.
12. I like it. All right, so here's what I'm gonna do on this guy here. Basically, because we're not doing this whole hoisting thing, I'm actually gonna like put this over here. And what I want to do is actually like map through this. So we're actually, what a map is doing is creating a new function, a new array. So basically, I'm gonna say like new numbers. And that's actually going to be equal to numbers dot map. And here's the interesting thing with map, like, again, we can pass in a callback function the same way we did before, but let's actually see how we can do it a different way. Remember, we can kind of like pass in another, like, we can, functions could be handled different ways. So let's actually do the fat arrow function here. That will be this. Yeah, and honestly, because we're only going to do something on one line, we'll actually just keep it on one line. So I'm gonna call this number so y'all understand what we're doing here. Number times, what do you want to times it by? 2 is boring. Give me another number.
2.1.
21. I like it. I like it. The function's drinking age. So basically, what I'm doing here is new number will equal to numbers.map. And if you can and basically what we're doing is we're passing in a function, a callback function. That callback function is basically it's saying like it passes in a parameter, and as you can see, it actually hovers here so you can see it. The parameter is number, so every time we loop through, the parameter of number would be what the first time around? Starts with a 1, ends with a 1. All right. Maybe I'm not explaining it properly, but basically, when we're looping through the map function here, we're actually going to have 1 as our first element. It's going to run the logic on that. So number will be 1 the first time around. Bam. Bam. So 1 times 21 is going to be 21. Then we go to 4. 4 times 21. 8 times 21. 12 times 21, and then that will be our new array number there. So the next thing we have to do is actually redefine text here. So text equals new numbers. I think, unless we have to like represent it a different way, but like basically it should just kind of give us a list of our numbers here. And as you can see here, our map basically did exactly what I mentioned. So we have 21 as our first element here. We have a comma, 84, 168, 252. So map, basically what we do is map is basically like creates a new array based off of the old array and based off of like the callback that we kind of tell it to do to manipulate the value in there. So basically, again, our number, our original array, please take a look here, is unaffected because we are not manipulating the original value there, the original numbers there. We run this, bam, we have our little, give more space, colon, run, bam. All right, so as you can see, our old array is over here, our new array is over here. Returns a new array, doesn't change the old one. Cool stuff. Reduce is basically like again very similar to this, but it reduces an array to a single value by applying callback function to each element and an accumulation of that result, basically. So long story short, again, it doesn't modify, but it's basically another way of kind of like bringing it down. The callback function is used to like basically, yeah, kind of like, yeah, it does what it says, reduces the array based off of your callback function there. Because your eyes are glazing over, we'll kind of continue on. Basically, that is higher order functions, callbacks, and array methods. So why do we need these? We need these to actually interact with the DOM, which is our document object model. So as Dom says, nothing stronger than family, and you'll see why that family tree is so important in the DOM. So again, we remember the whole structure of our HTML, CSS and stuff like that, that builds out a DOM, that like the JavaScript engine, our browser basically takes out those elements and turns it into a digital representation that we can manipulate via JavaScript called the DOM, document object model. And it's time for us to DOM it up. And before we DOM it up, we have to kind of learn a couple of things called the rest/spread operator and array and is array, and why we kind of need it in this world of DOM manipulation here. Apparently, they hated each other in the movie. That's why like The Rock just ain't in new Fast and Furious movies. So fun fact there. All right, so let's go into the rest spread operator. So again, this was introduced during ES6, and it's kind of like this useful operator, kind of basically spread out like your array structure for, or your object structure for use cases in particular, like aspects like what we're going to use on the web here. So I don't have a good example for this for you guys. Let me see if I can dig one up. Yeah. Yeah. I mean, all right. So I guess that's it. I guess that'll do. So basically, here's a good use case for this. So let's go back to our lovely little example, our little JS fiddle over here. So we have our numbers here. And basically we have, let's kind of, oh yeah. So, oh, beautiful. We even have a new set of arrays already here. So what the spread operator really does is it gives us the ability to kind of just say like, yo, give us everything from like the array or object that we want and in a easier fashion. So basically beforehand, if we wanted to make a new array, we would probably do something like, hey, loop through the array, put everything in that new array, loop through the other array, put everything in that new array. We don't necessarily need to do that anymore. So let's actually, let me show you an example of like the spread here. So if we do something like const, combined numbers, we can have this equate to these two arrays by using the spread operator. And we do that by doing 3 dots. It's funny every time someone enters, like I lose context of the browser, so cut that out. But basically, let's actually the syntax for this is 3 dots and then like the array that we want. And what's kind of cool about this is now we can kind of just say like, oh, all of those numbers in the array and all of those numbers in the new array here will equal our combined numbers. Let's actually get rid of our current text here. I'm going to get that out of here. Our combine powers make cap and planet. All right, I'm amusing my own self. Don't mind me. All right, so instead of numbers here, we have this new array called combined numbers. And what this does, as you can see, is like we got our numbers here. It spreads out. Basically, think of it as unpacking a suitcase and putting everything in a new kind of like place. I would like to say spreading out your clothes from unpacking your suitcase into the dresser drawers of like of your apartment, and you can kind of do this for as many like arrays or elements that you have. So now we have this new numbers here. We spread it out, and if we run this right, bam, you can see that we have this new combined, our powers combined makes a whole new array with the old array elements here, and then the new elements here. So basically, kind of cool. Instead of looping through or kind of having like multiple loops through our functions to kind of put everything in one array, we could spread it out and place it all in there. That makes sense, guys?
Professor, can you hear me?
Yes.
Quick
Yes.
question. What does the 3 dot mean again?
Oh, basically that's the syntax for the spread operator to basically say like it doesn't I don't quite know if like there's a meaning for it, but it's just the syntax to kind of say like of like spreading out all of the elements in that array into something else. So what would be a good way of thinking about it is like when you see those 3 dots, just know that you're unpacking everything from what is next here. So when you see those 3 dots, basically it's spreading out all those numbers or into this new array called combined numbers. You see 3 dots here, it's spreading out all of the elements of the new array into those combined numbers. Does that help?
Yeah.
Okay. So long story short, um this is kind of important because we're gonna go into these elements on the DOM that are like array-like objects, but they're not arrays. So we can't kind of like run the tools and tricks of our trades from basically what we've learned here from our higher order functions. We can't run our little maps, reduce, forEaches on something that is array-like and not an array. Um, we'll get into why that's important in a little bit. We also have this concept of Array.isArray. Long story short, what this does is in the world of JavaScript, our arrays are technically I always say like object prototype chain of an object. So basically, it is technically an object pretending to be an array, but like the way JavaScript handles it, it knows like, all right, these things in order is an array. But when we start traversing things like the DOM, we'll have arrays or things that look like arrays that aren't arrays. So we can't really use array functions on them. So a good way to kind of check to see if something is an array is be like, yo, just ask, yo, are you an array? If not, then we can handle it accordingly. So you're about to learn about the DOM, why we care about it, how to manipulate it, searching it, traversing it, so on and so forth. We'll get into a little bit of changing it. We're getting close to 8, and I want to give you all a little bit of time for some labs. So basically, we got to remember what the DOM is and all that jazz. So let's get into a little bit more of DOM, the sequel. Sad story is I don't even think I finished the first Fast and Furious movie, yo. I think I just remember the end. Like I owe you a car. But what's inside the DOM? This is a little funny bit here. We have the thinker and then the overthinker when they see the structure of a DOM. You're like, sweet baby Jesus, it's too much there. But the DOM again is this like it's this structure, and I'd like to think of it as this. So basically, we've talked about how a previous analogy was kind of like, we have like the blueprints, the architecture of our website with HTML, CSS. The DOM is basically the digital representation of it, so you can swap bricks out, yada yada yada. A good way for thinking about it when we're like manipulating it is thinking about it in the sense of like the HTML, CSS stuff is kind of like we could think of this world as it's basically like a puppet, and basically the dot like the actual puppet dead on the floor because it has no movements, it's unable to do anything. It's like the HTML and CSS, but the strings up to the little T shape with the dancing puppet. Let me see if I can. I know y'all be liking visuals out here. Let me see if I can do this. There we go. But the strings of the strings and like this little T-shaped structure here is our DOM, which gives us, the ability to kind of move our HTML elements around, give it the life blood and feeling of life on the page. So let's get back to these legends. It allows it allows the web page to render first and foremost. So basically, it allows like that puppet to kind of like come up to life, render to us. It lets us respond to user events. Like you click a button, something happens, and it changes based off of like our user events. So kind of shameless plug out here. I'm just gonna pretty happy how this game turned out, but hold on, let's see the whack. Maybe yes. Bam, there we go. That's all I needed. All right. I'm out here fumbling. There we go. So, um, remember like our user input can be as simple as a click, bam, to bam, basically hitting elements on a page here. So I gotta fix that. But basically, the idea is we actually, once a user interacts with an element, we can kind of make that element do something else. So for me, it creates the illusion of actually like someone a character getting hit, but it's really like on click, change the user, change the mole photo to make it feel like someone got hit. User events. Okay, so the DOM. And this is why the thinker over here was like, "Oh my god, overthinking." But again, this is kind of why I mentioned like it feels like a puppet string and stuff like that too, but this is the HTML representation of a page. We all remember it, we all love it. We're all going to make a livelihood out of it in a couple of months, but basically an HTML page kind of looks like this. But then when the DOM gets a hold of this and interprets it, it turns it into something closer to what we see on the right here, where every like the top level parent will always be the body, and then trickling down will be the elements on our page based off of our HTML instructions. So let's make this a little bit more engaging. So guys, what would H1 be from our structure here? If this is our HTML and this is our DOM structure from interpreting the HTML, what would HTML be here? I mean, sorry, what would HTML, what would H1 be here? All right, someone has to answer. I gotta make sure y'all are alive out here.
Hey, Vasio, can you ask the question again? It got a little confusing.
Oh, and yeah, sure. So basically, the H our HTML representation of our page is here. And when the DOM gets a hold of it and interprets it, it creates a little tree-like structure on the right here. So if we are following the instructions from our HTML structure here, what should H1 be?
Oh,
Hello?
hello.
Hello?
Exactly. See, I knew you guys knew this. It's my fault. I am the problem. My exes were right. But anyway, what would P be in this case?
It'll be check out my. I don't know if that's finished, but it'll be check out my.
Um, Close.
There's two.
But basically the P tag is actually going to be the whole collection of everything here. So basically it's everything here. So the text, which is the first element, you're on the right track. What would that be?
Oh, check out my. Oh, and then A would
Yes.
be page, and then okay, okay.
Yep. And A, what would that be?
The link.
Yes, exactly. The A tag link to page there. And then what would the last text be over here?
It's the best page out there.
Yes, exactly. So for bonus points, no one who answered before, because this is an easy give me freebie, what would the last P be on this page?
Come back soon.
That's right. Bob's your uncle. So you can kind of see how this HTML structure is interpreted into this like tree-like structure once the DOM gets a hold of it. And the joke is nothing stronger than family. As you can see, everything is kind of connected to the body. All siblings and parent structures out here. The DOM is a tree. So, there's a root node, which is the body, and the branches into the other nodes known as its children, family. So our H1 to P tags are basically the children of our body tag here. And the rules are really like each node can have 0 to many children. So, basically a node can have 0 children. Can y'all point out one or two of the nodes that has 0 children in this structure here?
The P at the bottom.
P in the bottom, and we have one more.
H1.
Yeah. These are the rich aunts and uncles out here having no children. Then like another rule is nodes can have 0 to 1 parent. Can we take a look here and see which one of these nodes has 1 parent? Many of them have 1 parent.
Isn't technically all of them?
Yes, technically all of them except the parent. I mean, except the body here. Because the body, remember, nodes can have 0 to 1 parent. The body has no parent, so that's 0. But H1 over here has a parent of body. P tag over here has the parent of body. This P tag here has the parent of body. And we like back to the top rule here. Each node can have 0 to many children. Basically, this P tag over there here has 3 children. So text, a text. So this one has a bunch of children. These two have no children. This one is basically the parent that birthed it all. And nodes can have 0 to many siblings. So as you can see, H1 has basically we look at our P tag here, we have siblings here, but our P tag here and our H1 here, no siblings. Make sense? Yay, nay, maybe so. All right, I'll take that silence as a yes. I know it's getting to 8. I'm gonna start just giving y'all labs. Be like, another one and another one. But basically, what's cool is we can actually check the structure out by looking at our dev tools on our browser. So let's kind of go into maybe here. And if we kind of inspect our little element here, like Shift J, bam, no, that's downloads. Psh. But what I like to do is actually just hit the inspect element here. This will actually open up our little dev tools here. You can kind of see the tree-like structure of our HTML document here. Bam, 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 bam. What's cool is it actually highlights it too. So, bop, 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 bop. And you can kind of see how our demo here has basically all of the elements from our little code example. But if we kind of scroll up, you can see our body holds everything. Our H1 is a sibling. I mean, not sorry, it's a child of the body with no siblings. Our little element here is a H2 with no siblings, but a parent of the body. And it kind of feels very similar to the structure that we just saw. That little DOM tree is kind of how the page works. So what's kind of cool though is when you think about it, in JavaScript, you can kind of delete elements. So you can delete nodes from a tree. So just quickly dig up. Move. Well, I realize like we have a page inside of a page here, so that probably won't work the way we were thinking. But basically, say if we do something, let's test this out. We can run a little code here. Run code here, can we? Wake up. There we go. Let's get. So remember, how do we reference our document? We're going to reference it by document. That's the window to our whole page. As you can see, it actually highlights the whole page when we click on it. So we have our document here, dot get element by ID. And if we kind of do the same structure that we did inside of our JavaScript there, I want demo. Get element by ID, demo. Bam, we'll see that like, hey, it has the node of that p tag there. So what we could also do is like dot, hold on. Sorry, it's been a minute, so I actually have to like Google this and remember what the hell we're doing. So basically, what's cool is, remember these nodes can be removed. We can append things to them. We can do all the manipulation we want. So we do something like remove, get that crap out of here. So as you can see, that actually removed like that whole demo ID by us basically saying get element by ID dot remove. This is kind of like the inner workings of us manipulating the DOM based off of our functionality. So picture if you put this in a function, you run a function called press, and you press a button, and that button actually equates to this little line that we just generated here. That'll just remove a whole element from our page. And all right, so first and foremost, that makes sense, right? Yeah. Yeah.
Yes.
Okay, cool. So here's the interesting thing, this looks a little, these examples are cool, but they don't really hit because of the fact that you're just like, why the heck are we removing text and stuff like that? Here's an example of a small like project I did back in the old days. And it was it was a form again, as I mentioned, guys, like this is the reason why I tell y'all to like take a look at this whole research and research development stuff. A lot of times in the web you're just making forms, you're making buttons, you're making stuff like that. But basically, an example of like what we did just there was if you click on this button here, I created this element where you can kind of add new input fields here. But if you press this button called remove, bam, we remove that line inside of our list of models that we wanted to change. Hit this remove button here, bam, it's removed. We're removing basically a whole div that holds all of those input fields like on the page. And do you see how like that whole remove element can turn into this more engaging page layout magic here, right? Like, so let's say we have a function called append as well, and an add in on the DOM. We're adding HTML to make this kind of like extend, but then we have this element to actually remove. a unit. So we are hitting dot remove on a whole div, removing that from our page. I know it kind of feels like the stuff here we're just what we're doing is super basic, but it translates to bigger things on the web when you start playing around with this in the wild and you're making your own projects and stuff. Make sense?
Yes.
Cool. I was gonna say I take that silence as a yes. I'm glad. All right, so why do we care about the DOM? We care about the DOM because it made 10 movies. But basically, we care about the DOM because it makes it possible for us to manipulate the DOM based off of like like the DOM's content and structure. Very similar to what I just showed. You can kind of take that baby step of like removing little divs based off of like a getElementById dot remove or getElementById dot inner HTML, put this HTML in this div. You can kind of add HTML elements through to the page. You can remove HTML elements to a page. You can do a lot of other cool things there. And this is kind of why the DOM is so important. You can even and I remember when I was a junior, I did this way too much, so don't do it. But like basically the idea is it just shows you the power of like your little JS here. Oh yeah, it's here. So let's go back to our little example here. Our little getElementById in our HTML. Let's do basically the same thing here. Document the getElementById, get fragment. Get by ID demo. All you do is like bam style dot color equals blue. That should, yes, change the CSS of our page via JavaScript to change our color of our text to blue. So we can add, remove, style, change the DOM in whatever way we really want to by just manipulating the DOM and understanding how we can kind of, like power the DOM. So nodes have many attributes. So nodes in JavaScript are represented in like JavaScript objects, but here's and they possess like attributes that defined as like JavaScript properties. So one of the things I do want to mention is remember how we kind of talked about oh yeah, we'll go into getElementById as we saw, but you can get it in different ways. But the document object is really, it serves as this global reference. We saw how we reference document to get the global like whole page. And then basically we started to narrow down where we wanted to manipulate our DOM, the ID of demo. So we can kind of like we start with the document of the DOM, and then we start to narrow down to actually like play around with like what what things we want to do with our DOM there. And we can kind of again write that in JavaScript code. Searching the DOM, we've kind of played around with one of these already, which is getElementById. So this finds the node with a certain ID attribute, and this is why when you're building out your HTML structure, you should only have an ID of one thing, and it should never like there shouldn't be another ID with that same thing on your page. So for example, on our last page, we had demo as an ID. We should never have another demo somewhere else in the page. There should be only one unique ID name. So you can have multiple IDs, but you can't have like multiple IDs with the name of demo. So as you can see, it always says get element, so it's singular by ID, and basically from there we can kind of manipulate and play around with that. But we also have the ability to get certain classes, so like a number of them, through another method called getElementByClassName. So this is kind of this allows you to grab more elements on the page. So let's say we have a class of input field and we want to grab all of those, and based off of something we want to interact with that in a different page in a different way. So we can basically grab all of those, and that is basically that gives us a bunch of nodes in an array-like structure. We'll go into what an array-like structure is compared to an array in a little bit, but let me kind of show you an example of what that would kind of look like. So I want to grab all of the elements by class name of input on our little page here. So, we have our name, last name, street address, city, all this stuff. So, let's say if I were to just kind of like submit this without doing anything, as you can see, we get this whole like blaring red thing over here. And a good example of how like this kind of works is we get we basically want to share what's required. So we get element by class name, and maybe we have an input field or like required input field, and we get element by class name required input field. So when the user presses a button here and it's called submit, basically if these input fields do not have anything in them, we basically go through all of them or the ones that were filled out and basically give it this red blaring color, put a required on all of them to basically inform the user, yo, bro, you cannot move until you fill these out. You see how get element by class name can kind of work in this kind of way here. All of these things work together on the page. It kind of makes our website our website. We can also get element by tag name. So basically what we mean by tag names is like the actual HTML tag. So we can actually grab all divs, we can grab all H1s, we can grab all P tags, and run logic similar to what we did in our previous example based off of that. We can also do query selectors. So basically searching the DOM using CSS selectors all the way to kind of like particular selectors like, our like our ID of container all the way to container first child. So we can basically say something like, yo, I just want to get the class of container, but I only want the first element in there. And we can kind of grab these elements in our DOM based off of that. The DOM is all connected, so we can kind of just traverse them like that way and actually grab the first child or a sibling or so on and stuff like that. So when we grab elements like get element by tag name of divs, we would get a list of node objects basically in something that looks like an array. But remember that whole earlier concept of isArray? If we actually run the class function of isArray on that div list, so let's say we grabbed all of these divs by tag name, and then we basically were like, yo, give me like the array div list, will actually generate false. So wait, what? Like basically we're getting this array, but it's false. Like we can traverse this div list of like with the bracket of 0, we'll get the first element very much like an array. and it walks like an array, it talks like an array, but it's not an array. So this is something to watch out for, because you can be out here debugging your code and basically running, you try to run a map function on your array, and you're just like, it's like map cannot be run on error, map cannot be run on something that's not an array, and you're just like, wait, what are you talking about? This is an array. A div list is an array. If I use bracket 0, I can grab the first element. If I use bracket 1, I can get the second element, so on and so forth. So why can't I work this like an actual array? And it's because this is a good and a bad thing, but what's kind of cool about this is like this array-like structure is kind of like this node index list that one, it does not, it's kind of something that's more similar to the DOM and not a JavaScript array. What's cool about that is like if you manipulate basically the page on another line of code and you actually have this div list, basically, let's say you added another div, that list will actually still have like that new div on there. So like basically this is almost like a living array, while our traditional JavaScript array is going to be like static. So we have this kind of like live dynamic array like object, but we can't run our JavaScript primitive tools and iterations on it. So that's a little unfortunate, but there are workarounds for this. So here are a couple of the workarounds. But what I really want you to kind of focus on is this spread operator here. This is kind of the new way of handling, like, spreading out the elements in your like in arrays all the way to node like arrays. And what's cool is once you actually do this spread here from your get element by tag name here, so your list of div nodes, it now is a JavaScript array. So you can now run all of your JavaScript functions, logic, all of the things that you wanted to do in JavaScript on there. But then remember, of course, this is then going to be a static array. So basically you turn this into an array, you deconstruct your div list when you're ready to kind of manipulate your actual div structure on the DOM. So yeah, traversing the DOM, we'll go through traversing, then we'll stop. You'll get like, then we'll go into like some labs and stuff like that. But basically, yeah, traversing the DOM, remember it's like this tree-like structure from what we saw before. So it's relatively easy to navigate because at any point, like, in the DOM, you are a node and you're kind of connected to some other node. So no matter where you go, you're still at a node, whether it's a child node, a parent node, or a sibling node. So all nodes are similar DOM navigate. All of these DOM nodes have this similar like navigation to them. Here's kind of like an example of how we can kind of traverse the DOM in one way. So, we have our parent DOM. We can kind of say, hey, what's the first child? And from there, we can kind of grab the child from the first element of the DOM there. Then we can or we can do something like grab the last child, and this will actually reference the last child there. So from there, you can kind of do a couple of other things. So if a DOM node has one child, you can run, first child or last child on that. So as you can see, first child and last child will actually work the same way if it only has one child on there. So traversing it from first child to last child is one way of kind of traversing your DOM. But then let's say if we wanted to play around with actually like interacting with the siblings of your DOM-like structure, we can use something like next sibling, or previous sibling. So let's say we're at this parent node, we go to the first child, we can use next sibling to actually go to the next node. next sibling to go to the next node, next sibling to go to the next node. We can even use previous sibling to go back, go back, go back. You see how traversing the DOM with these methods can kind of start to make sense because they're always connected in the DOM. All right, another way we can actually do this is, picture we're dealing with, we go to our first child, but then we kind of are like, we're getting lost here, so on and so forth. So I actually want to go up one. I want to go to the parent node. You can kind of traverse the parent node this way. So basically, parent node will actually take you up to its parent. Pretty self-explanatory, but at the end of the day, like this works for the last child, the middle child, the other middle child, all the way to the first child. It's always its parent. We go down to, let's say if we were at this child here, we go down to the first child. We can kind of go and reference that parent node, go back up. Parent child, go back up. Parent child, go back up. So on and so forth. Traversing the DOM, you can access them with these elements here. So you got element.children, which is basically what we have here. First child, last child. Last child, first child. Children will give you the list. Next element sibling is the pink over here. Move from one element to the next. Previous elements there. Next sibling, previous sibling. And if the parent node exists, basically parent node, you can move up in the DOM tree until you reach the body, which has no parent. And that's kind of how you can traverse the DOM. Oh, we kind of went over this a little bit, but like what's cool is you can then change DOM style attributes with basically things like its property. So for example, we want to do style.property, new style. That's kind of like an example. Style.color equals blue. So what we did over here in the JS fiddle is kind of similar to what that example was here. So basically, if you look at line 11, we actually grab the element by ID of demo, and then we said, yo, I want to access its style, and then its color, and then I want to set it to blue. I didn't realize you could do this, but you can actually use hex values too. But does anyone else have a funny color that they want me to change it to before we move on?
Maybe purple?
Purple, I like it. And I want to show y'all something cool. So I'm actually playing around with the hex color, which as you can see here, the hex color, hex color here. You can actually play around with hex color. I actually want to show you that like you can kind of grab this hex color and it doesn't necessarily need to be a set blue, red, pink, purple. You can actually grab its hex color. Let's run that. And bam, we got that purple right there. Pretty cool. So it can be the word of the color or the hex value if you want to be absolutely specific. Funny story though, a little tangent here. I used to like co-work at this space called Gumbo. It's the New York Game Collective. Fun times. There was a guy that like basically was working on a game called Flip a Coin for months. And then when I saw that Google did it, I was like, yo, bro, this dude like wasted so much of his life basically making this thing that Google just said, like, yo, hold my beer. But anyway. That's traversal. That's how you can change style attributes, remove elements. We kind of went over that. You can remove remove the child of nodes all the way to removing the parent node. So what's kind of cool is you can remove its child node, but quick hack is if you don't know the parent, you can actually be like, yo, old node dot parent node, remove its child. There's all these really cool ways to kind of traverse and edit the DOM because a lot of people have been working in the DOM and actually understand how much it changes. So event handling, we're going to stop here because I'm sure your eyes are glazing over right now. Let's kind of go into some of the labs. I'll give y'all, unfortunately, like 10, 15 minutes to kind of do the labs. Of course, y'all work on them inside and outside of the class, but here are the two labs I want y'all to kind of play around with. So the first one has to do with callbacks. It's called Accumulator, and what it primarily is doing is showing you how you can kind of like pass in a function to another function. So yes, accumulate lab here. You know the deal. What you're going to do is fork the lab, make the changes, do your PR. But the idea is like there is a function that will be passed into another function. And what you have to do is actually like build that up in this lab. So given a collection of numbers, you'll get a function to kind of square those numbers, and then it'll actually square them. And then, there's another test there. Again, what you do, run npm install, then you can run npm tests. If that doesn't work, run npm test -- spec / accumulator spec. You'll see it. Oh, sorry. Run npm run answer. And if that doesn't work, run npm test -- the name of the spec folder there. But once you run npm install, you should be able to run npm run answer and then test out your logic there. So that's your first lab. The second lab, it's a little harder. So like we all should work together on it. It's fun though. It's string manipulation. The idea is you're a vault breaker and you need to decode and encode the intel because we are in espionage land and you need to figure out what the heck's happening here. So basically, for an encoder, what you have to do is change the letters to numbers, replace the white space with $signs, then reverse its order. It's encoded. No one knows what the heck it is. So, for example, the Great Gatsby would turn into change letters to numbers. So, bam. Then you replace those spaces with $signs. It looks like this. Bam. And then you reverse its order. Bam. That does not look like the Great Gatsby at all. And then what I want you to do is write another
Professor,
function called decoder, which
Professor,
basically reverses it back, doing the
Uh,
same steps in reverse order.
Professor, you're not
Yes.
showing your screen.
Oh my goodness. Why didn't anyone tell me? All right. I got you. Just for that, another lab. But hold on, let me actually let's go back here. The lab I was talking about. You are a Intel decoder encoder. What you're doing is actually setting up these instructions here. So basically, Great Gatsby. The first thing you have to do to encode it is change the letters to numbers. As you can see, this is how it would look there. Replace the white space with $signs. It would look like this. Reverse its order. That does not look like the Great Gatsby at all now. and then write another function called decoder that reverses it back. So first you do the reverse back, then you replace the money signs with white spaces, then you change the numbers back to letters. It's now decoded. And because y'all didn't see this one here, the accumulator lab is basically you passing a function in to actually manipulate the parameters that will be passed into the accumulate of function here. So for example, you'll be given a collection of numbers, and it operates like square the number, then it should square the number, so on and so forth. As I mentioned before, first run npm install. That will install basically the specs to run the test. Then run npm run answer to actually test out whether you have passed or not. If this doesn't work, run the line npm test dash dash spec, the name of the folder there. And it's the same thing for this guy over here. So the first one is going to be encoder, and the other one is decoder. But if you run npm run answer, both of them should run properly. Okay. Thank you for letting me know I wasn't sharing my screen out here. All right, so I'm going to put this in our Slack channel. Bam. That's our lab 1. Bam. That's our lab 2. And I'm going to break y'all into groups. Yo, like for like 5 minutes, apparently. And we'll kind of go from there. All right, well, I'm breaking y'all in the groups. Any questions? Nah, we good. We Gucci. Cool. All right, guys, get out of here. I'll see y'all in 10 minutes. I expect the lab's done by then.
The form that Geraldina posted on Slack, I believe. It should be available for you. I checked the form today. You see, I'm starting the interviewing students. I'm starting this selection process, and I already sent interview invitations for some students. But you have to understand the following. Once I pick the students who, from my point of view, good fit for the program, like once I fill out all the seats, that's all. Even if you would be very interested in the program, the seats will be not available. So my point is, if you want to be there, you should fill out the form as quickly as possible. Okay? And please keep in mind that unfortunately this opportunity is not available for people who don't have either US citizenship or a green card. So in order to qualify for this, like the very first thing, and it's not my requirement, it's a requirement of the lab. They have like extremely strict security process. And if you don't have either US citizenship or green card, well, it's going to be nightmare. You'll not be able to get there. They won't let you in. Okay, that's what it is. So keep this in mind. So if you US person for migration purposes, then please, and you're interested in this opportunity, please fill out this form as quickly as possible. Because as I said today, I already sent like a bunch of invitations for interviews. I'm gonna start interviewing from Thursday, and you have to expect the email from me not email. I'm gonna communicate through Slack message at any moment. All right. The idea is that I'm gonna give you 2 days to prepare for interview. I'm gonna send you a couple of topics, research topics. You have to do research about like a couple of algorithms that I'm gonna mention. And when you come to the interview, you have to be prepared to elaborate on these topics. So I'm gonna ask questions, and then we'll discuss other things related to this internship. But it has to be done quickly. All right. Okay, because I know some of you not very good, like in terms of responsiveness, but well, it might be too late. Like if you decide like later, oh, I want to be there, it might be too late because the seats will be filled. All right. Okay. So I hope that everyone is listening. Everyone hears what I'm saying because I see a bunch of you have your cameras off. So I don't know if you're around, if you're listening, right? And by the way, it seems that I told you from the very beginning, we would like everyone to be visible on cameras, right? Well, you shouldn't treat this as like another class where you just you join Zoom meeting and do something else on the side. Well, because in this case, what's the purpose of being part of this program? I don't know, right? So that's all. That's what I wanted to say in terms of like announcements. So please, make sure that you address all these issues. Now, if you not interested in Air Force, right, then also let us know because then Geraldina will start working with you on the other opportunities because we have a bunch of them, right? She probably already mentioned this to you. We have a lot of different opportunities, but we need to start working on them early. We good? If you have any questions to me, don't hesitate to reach out on Slack. And remember, Slack is our main platform for communication. So I expect you to install it on your phones so that you respond quickly, not within like 3 days, but like within same day, like within 24 hours the most, preferably within 15 seconds, right? So that would be the best way to communicate. Okay, good? Great. I'm sorry, Hess, for interrupting. And well, thank you, everyone. Have a good night. I'm gonna leave.
No worries, and it's fine. Thanks, Dimitri.
All right.
And on that note, we're at 8:30 now. So everybody, I know y'all didn't have a ton of time to do the labs, but finish off the labs. I would say at home, but you're already at home, except for Luis. Sorry, bro. Go grab a Pret sandwich afterwards, man. But basically, I hope y'all had a good lecture. I hope it was fun. I hope it was informative and not too boring. But just remember, the DOM is basically where the powerhouse of the browser. You know how the mitochondria is the powerhouse of the cell. DOM's the powerhouse of the browser. So on that note, I'm gonna get out of here. Before I start making some more dumb puns. Have a good Tuesday.
Have a good one.
Good night, everyone.
All right,
Good
see you
night.
guys.
Bye.
Good night, everyone.
Have a good one.
Night.
Bye, guys.
Bye.